Welcome to the AI innovation space. We are your experts, and I'm Iyanu.
And I'm Todd.
We're here to offer our unique insights and hold conversations with top leading innovators in the world of AI and machine learning.
We dissect and discuss the often complex realm of AI in an accessible way and go deep in discussing the innovative technologies that impact our lives every day.
This podcast is sponsored by Ellumen, an IT contractor offering a creative and human-centric approach to medical imaging, cybersecurity solutions, training and support, and more. Ellumen's values of ingenuity and connection make us a leader in adopting innovative technologies for federal healthcare and beyond.
Visit Ellumen's website at www.ellumen.com for an overview of the services offered and to read our blog series on leveraging AI for your business. Thank you so much for listening, and let's begin.
We're going to just jump right to it. We're really excited to have you on, excited to, get into some of your experiences in the AI ML space. So Glenn, do you mind? You want to do a little bit of introduction about yourself, some of the things you've done, and things like that to get us started here?
Sure. So first of all, thank you very much for inviting me to be on the podcast. I really appreciate it. So my background was initially in the U.S. Navy. After my time in the U.S. Navy, I decided to go to college, and I really enjoyed it. I turned out to be really good at it, so I went for the next 11 years and finished with a Ph.D. In physical chemistry. It was all computational. We can get to that, because when I say chemistry, people think that has something to do with mixing chemicals. Mm-hmm. I did absolutely none of that. It was all on the computer. There's a lot of chemistry that doesn't involve any actual lab time at all. I think in 11 years, I might have gone in a lab twice. And that was just to talk to people. I didn't actually do any work in the lab. Oh, wow. So, yeah. But we did do a lot of computations from there. I graduated during the Great Recession, which was a very scary time to graduate, but I managed to secure a position in the U.S. National Lab System. This is a series of labs all over the United States. I worked at the one near Chicago, Argonne National Lab, which was originally built with the purpose of doing sustained chain reaction, but it was behind schedule and they were building it, like a lot of government projects. So they actually did that at the University of Chicago, as the story goes, underneath the squash court, but I'm not sure how true that is. So after my time at Argonne, I decided I wanted to go to a more engineering-focused lab, and I was really trying to get more into data science at this, and I went to the National Renewable Energy Laboratory in Golden, Colorado, which this is a special national lab because it's one of the few that was not built for the Manhattan Project. It was built afterwards during the energy crisis in the 1970s with the goal of improving the U.S. structure for renewable energy, which it still works on. So when I was there, I was able to do data science projects, and I really enjoyed it, and they were very formative for me. I decided I really wanted to go on this full-time and not be a chemist anymore. There was not a lot of appetite for that in the National Lab System. It's really unfortunate, but if you're a scientist, you really can only do the work that you get paid to do, that you're funded to do. So you can't really do a lot of unfunded research. And I was not able to secure funding for machine learning, so I just left science and became a data scientist full-time. I went to a boot camp to see if there was anything that I was missing. There wasn't, but it was a fantastic place to really develop a really great network and meet a lot of people who were very interested in the same thing, which is exactly what I did. From there, I went into data science, where I've been ever since. So that's sort of my background. In not really short, I talked for a while there, but that's sort of all the parts of it. We can talk more specifically about specific parts of that.
I see. Thanks, Glenn. So I'm kind of curious. So you said you went to a boot camp, but you kind of already had all the skills you're looking for in machine learning. So did you kind of pick that up on the side when you were working on your PhD or some of these labs that you worked at, or can you explain a bit more how you came to have those skills?
Sure. Yeah, when I was at Argonne National Lab, I became very interested in studying problems that were outside of what we could do using electronic structure theory, which is the tool set that I had when I was as a chemist. So I looked into it and I was very interested in moving. They had all these ways of doing it. I started to learn about it there and I wrote grants to do it, but they weren't funded. When I was at the National Renewable Energy Laboratory, they made a deal with me and they said, hey, you only have to use the first 40 hours to do what we pay you to do. And past that, you can do whatever you want. So I used all of that free time to study data science and to work on data science projects. Specifically, I worked with a research professor at the Colorado School of Mines, which was very close to us. And then from that collaboration, I learned a lot about machine learning, how it worked, and what to do it. So I would say I learned it on the side through being a scientist, through working on projects outside of my normal business operations.
I see. Yeah, that's awesome. They allowed you to do that. I see one of the first roles that you had working more as a data scientist and in machine learning was with the Albert Einstein College of Medicine. Can you describe more on that role and what you were working on there?
Exactly. Yes. This is one of my most interesting roles because my actual title is instructor of medicine, which is very strange because I don't really know anything about medicine. But it was a medical school. Their hiring is a little different. So, they'll hire, I was part of the Department of Medicine. So that was what my title was. My actual job was, I did teach one class with an MD PhD in, one of their programs to doctors, and it was focused on data science, and it included a lot of machine learning. In addition to that, I also did a lot of data science with hospital data. So we were able to do that. It was sort of like we were an internal startup that was part of the hospital system. And it wasn't just Albert Einstein College of Medicine, although that's where we were based. It actually involved, this Albert Einstein College of Medicine is wholly owned by Montefiore Medical System. So it's part of this larger medical system. We looked at data from the entire medical system. So we looked at a lot of different things in there, but there's one that I'm especially proud of. I did this in conjunction with an MD PhD that I worked with, a data engineer. There are certain conditions that if you have them, they could compress on your spine and leave you paralyzed. Well, we wanted to see if we could see these in X-ray. It turns out that's very, very difficult. But we thought, well, let's try to make this into an operations problem instead of a healthcare problem. So we didn't want to try to do something that doctors are already very good at. We wanted to make the system operate as efficiently as possible. So we looked at it and said, hey, the radiologist is going to read this. Radiologists don't diagnose the problem, but what they do is they say what they see in the X-ray or the imaging scan. So it doesn't have to be an X-ray. It could be a lot of other different ways. It could be an MRI, it could be a CT scan, etc. But the idea behind it is they look at that and they write down what they see. So we said, why don't we read that text and see if we can say if this condition we're looking for is present in that report, and then trigger an automatic alerting system so it notifies the doctors if this condition is present. So it did. It actually worked very, very well. So well that I spent a lot of time trying to figure out what I'd done wrong with it because it was almost too good. So we didn't want it to be too good. We want to know why it's working, and it has to work appropriately. Actually very fortunately, it worked really well. But it didn't support my view that the system was working. So then the question is, okay, now we got it. Now it needs to be rolled out at a larger scale to the hospital. There were some issues with it. We fixed those, and now it's ready to roll out to the system. And that's where I first learned that you really have to have a plan in MLOps to expand, to send things at scale to a system as large as this medical system, which is kind of unfortunate because there was no system in place. So that is still being put into my knowledge, still being put into practice at the entire hospital system. But that involved a lot of work with the doctors, involved a lot of work with different parts of the hospital as well. It was a very informative project. I'm really proud of it. I'm very happy that it worked.
So I just wanted to, if you don't mind sharing a little bit about, some of the AI tools or algorithms that you use to be able to implement that project, if that's okay. Was the data that you used, was it publicly available, or was it more, internal data sets and things like that?
No, none of the data we used was public at all in any way. It was all very private data that was used by the hospital system. Yeah. Without that data, it would not have been possible. But but it was all no part of that was public in any way.
Okay.
But I can go a little bit more into the actual tools that we use.
Yeah. I would love to hear about that.
It's free text. So one of the things you could do, this was a while ago, this probably isn't how anyone would do it now, but what we really wanted to know is, hey, we have these conditions, parts where we know this condition is present, and we have parts where they're not. What is the overlap between those two different things? Well, you can't do overlap of words, but you can do overlap of vectors. So we could vectorize the entire report and then see if we had what percentage of overlap of these vectors, what percentage actually means that a condition is present. So to do that, that used Gensum, Doctivec, which then was much more prominent than it is now. Now, if you look at it, some people probably use BERT or something even beyond BERT to do that, more like transformers. But at the time, we used Doctivec. It worked very, very well because that's all you actually needed. That then fed into a neural network. There was a classifier that said if this was present. So that was the way the system itself actually worked.
I see. Well, thank you so much for sharing that, Glenn. It sounds like very interesting work that you were doing at the Albert Einstein College of Medicine, and hopefully one day that system that you were working on can be finalized and fully implemented on the operation side. One other thing that I'm aware of that you were doing there is, weren't you also teaching some courses to doctors? Can you tell us more about that and any insights you can share on that or interesting observations?
Definitely. That was a really interesting part of the position, was that we had to develop a course for their clinical research training program, which was for doctors in order to, they already had their MD, and they wanted to do research in their program. There was a separate program just set up so they could do this, called their clinical research training program. We taught classes in that program. This is a course I co-developed with my coworker who was an MD Ph.D. And that was great because it really helped with a lot of, it's talking directly to doctors, because doctors are fantastic to work with. They tend to be great students. They're brilliant. They're really engaged. So, which is probably how they got to where they are. So it was a really great experience to work with them, and teaching them how they can cast what they do into data science problems was a really important thing. We also went over machine learning with them, but the reality was we didn't expect them to be doing machine learning at the end of it, but we expected them to understand it on a deeper level so they could say, hey, I have this problem with understanding cytokine storms. How can this be solved using data science? So, and really teaching them how to do that, it was very rewarding because the doctors that we work with, they did very well on projects with that. Some of them we continue to work with afterwards.
I see. That's excellent. That was a good experience for you and both the doctors, I'm sure, as well.
That's awesome. Also, can you really share about like some of your thoughts around how, either natural language processing or computer vision as how it's developed over the years, right? From the project you worked with at Albert, all the way to like where it is now, with Synthesia and some of this really nice natural language processing software, some for voice now coming out and things like that. Any thoughts?
So they have continued to advance so rapidly. I feel like where we were at was at the very beginning. It was pretty early on. Now they're really almost like professions in and of themselves, where you'll have data scientists who specialize in computer vision or NLP. I think where we're at right now, I think the really interesting thing is when you see these models that's really merging them, where you have text to images or images to text. So images to text has been around a lot longer, but there's things like these new things where you have text to images. That's a super interesting area.
Yeah.
That wasn't possible when I started. But they've really gone pretty far, pretty fast, especially with these. They're, at the time, maybe they existed, but we didn't use them so much. We were still making vectors and looking at vector spaces of words, but now people are using trained language models in these very large scale models, which the most exciting one that I've heard of is Bloom, which is actually made by Big Science, which is, they'll tell you everything they did about how they trained it, what they used to train it, which that's a very exciting because it sort of takes it away from big tech companies and makes a massive language model. Can be used for language generation as well as classification or regression. In addition to, or away from the tech companies and into everybody's hands, to everybody that can do it. So if you need to do retraining, you know exactly how it was trained. Now, if you want to do retraining of GPT-3 or BERT derivatives, it's not so easy to do, and it can be very expensive. So even if you just want to do small changes to them, but if you have a language model that you know everything about, it might be easier to do. So, but I feel like that's where the area has really gone, is these massive language models, and everybody's really interested in sort of like text generation, because after GPT-3 came out, it became a big thing to say, oh, what text can it generate? Now, I wasn't so clear that it was that big of a deal. Everyone told me, oh, this is totally game changing. But if you ask it questions that aren't trivial, but that are more difficult, it does a terrible job. So, which maybe says maybe there's not such a huge amount of intelligence under it. So, and what it's really doing is an extraordinarily good job of sort of merging together different ideas in different ways, which is what you would expect from a large scale language model.
Yeah.
If it's something outside of the system, yeah, it's probably not going to do very well. So it's probably not as real intelligence as we think. It's not towards AGI. It's more towards really good text generation, which is not a bad thing. That's fantastic.
Yep. I agree.
I see. Yeah, thanks for sharing more on the natural language processing, kind of where you saw it going in the recent years and on GPT-3. Very interesting. So, yeah, I guess moving on from your role with Albert Einstein College of Medicine, I see that you also worked with Caserta to build a recommendation system to use fitness data with machine learning. Can you talk more about that role and what you guys are working on with there?
Sure. This was my foray into consulting. So this was a boutique consultancy, which has since been absorbed by one of the larger consultancies. But the idea behind this was there was a large fitness chain, and they really wanted to have more online content, and they really wanted to use they really wanted to use a recommendation system for this. The big challenge with it was they didn't have any data because the system wasn't currently working. So it's almost like we had to develop a model from data that was synthetic, because we didn't have any actual data that we thought would fulfill all the requirements at the time. So, and this involved trying to merge everything together with the system as it currently existed with an app. So from that perspective, it was very useful because we had to understand how the app was structured, understand how the data was coming into it, and then work inside a cloud environment. And something very interesting I'll talk about with that in a second. And then serve that data back to their databasing system so they could then look at it in the future. One of the things I learned was that the cloud providers tend to have very, very good tools, but they can charge you a lot of money for them. So if you spend the time to develop your own tools, it can be a huge value add and just reduce cost. So we took this from being very expensive to being very reasonable very quickly, without using a huge amount of development effort. Now, the problem with that is that it does have some development effort, and they have to be able to support it after the consultant leaves, because consultants are only there for a certain amount of time, and they don't want to pay them anymore, so they leave, so then you have to support it on your own. So all the systems had to be developed in such a way where they have really good test coverage, where they have really good documentation, so that when the consultant leaves, the data scientists or the developers who work there full-time can still support it. So, but the consultants can be very good at building things for you firsthand. But in this case, it was a good lesson, one, in cloud provider systems that they have, and the second one in and what's the right way to use those, and the second one, and how can you develop things without good data, which is a big problem in consulting in general.
Yeah, I see. Thank you. So if I understand correctly, you guys, when you were working on that, you initially were using like one of the large cloud providers, and then due to costs, you have your own cloud environment that you stood up. Is that correct?
No, we actually use the cloud environment, but there are many things the cloud providers can have that are specific to different AI tools. Like there's different NLP systems they'll give you, and there's different computer vision systems that they'll just let you use theirs without developing it. So specifically, if you want recommendations I think there's AWS Personalize, which allows you to get recommendations using their system, which I don't know how, they don't tell you how it works, but I would assume it's a neural network under the hood. So, and you can use that, or you could develop your own system and just stand it up in their infrastructure. So, for example,
that makes sense. I see what you're getting at there. Just developing your own tools in there to use in their cloud environment instead of their tools that they provide that are more costly. Okay.
Yeah, that's the idea behind it.
That's awesome. So, also, I wanted to move, to your role at Union Crack, right? You were, doing some automated processes through client predictions and data ingestion to reduce the times for predictions and stuff like that. So, I've always been interested in how, to improve efficiency in companies just in general. So I'd like to hear a little bit about your experience there as well.
Sure. So this was a Series A startup when I joined, and they did have a data science group. I was the last member of the group to join. I was before the first data engineer, but I was the last data science hired to start there. The problem there was that there was a system in place. It currently used just a virtual machine with some code on it and a few models that had been developed over time. So this wasn't very scalable, and it wasn't very extensible. So changes could actually be very, very costly, very expensive to do. So the idea was, instead of using this system, let's redevelop the system that we would want from the beginning so that all of this is scalable and extensible. So each part of this exists in the environment, which was also a different cloud provider. And it can scale up to the workload that we need. And what we were trying to do was say, okay, we have a product that's being sold. What is the forecasted demand at every location it's sold for this product based on previous sales data? So this turns out to be a very large number of time series models. So, but it could be a time series model for each product, for each location. So you can see that it has the training cost is very expensive. So you have to develop a system for doing this, which all of these different ways of interacting with it are set into a system, a single system, which we developed a single system for this. And that this can then scale to what you want. So you get your sales data in, you have a data engineering pipeline that sends it to the modeling system. You do your modeling, which includes training and predictions, because the data changes every week. And then from that data, you have to say, which model do we want? There's many different time series models, so it's possible the data itself contains information about what is the best way to model it. And then all of this has to be efficient and extensible, because there could be many thousands of these predictions being made every week for a single client. So, because it was a B2B business. So in that, we had to write a system that did all of this inside the area without using a lot of tools. So it was a huge amount of Python coding to develop an entire system to do this. So that was where it was. So the efficiency was, it was all written by just two of us, where we wrote many, many Python scripts that interacted with all of the different libraries that we needed to get these time series models. And there were a lot at the time. Profit was out, but some new ones like Darts weren't. So then we were able to do that. We developed that system. Then we scaled it. Then we profiled the code to find out where the problems in speed were. And we then changed it. So we made it very scalable for this. So then instead of a single person running code for a single client, now the system runs all the client itself. So all it needs is a trigger, and then it runs from end to end.
I see.
Yeah.
I see. So how did you bin the time? Was it in seconds, minutes? Like what was that like, structuring it around time?
Well, the idea is that you're going to send this. So when you talk about a lot of these cloud systems, it's going to have to be how many of these can you get to run at the same time on the system? So how scalable is it?
I see.
In the code. Yeah. So for that, we used systems like Ray, where we did large-scale multiprocessing in between a lot of different machines. And then it's just how many machines do you need in order to get it to run in the time period you needed to run it.
Makes sense. Makes a lot of sense. Thanks for sharing that.
Yeah, one other role that we wanted to get into before we get into your current role is you were with Curate Insights as a data scientist working on automating processing through client predictions and data ingestion. Just love to hear more about that role and anything you're able to share.
Sure. So this was my second venture into consulting. So all of these are through client systems. So for each of these, I work with different client groups with it. Now, one of these client groups specifically, which was the main thrust of my work, was with a regional healthcare provider. And what they wanted to do was make recommendations for their clients to say, this is information about you, about your healthcare usage. This is the best plan for you. So they tend to have a lot of different plans, and they want people to have the best plan recommended to them that works for them. Now it's up to them ultimately what they choose, but they want the recommendations to be the best. So the way that I approached this was as an unsupervised learning problem. So, and the data that from this was data that we went out and got. So it's not publicly available data, but it's also not data that tells us anything about any individuals. And then I was able to use this data to develop a system for segmenting, and then I connected those segments to different healthcare plans. So then we had a system that was able to do this, that was sort of engineered for the particular problem at hand. I can't talk too much about that because I'm still under non-disclosure statement. So, but that was how the system worked, and that was what it did. So it wasn't so much operating at scale in this case, it was so much as how can it really give them the information they need using a system that is full-featured enough to meet all of their needs. Their needs are we have to develop the recommendations, but it also has to be supportable internally by them.
Okay, so the health plans that it's recommending, are they for the company or the client in this case to offer to their employees, or are they on like an individual level for specific individuals within a company?
So the one that I looked at was internal, was for the company itself, but the idea was to then for them to take that as proof of concept and move that out to their entire client base. I
see. Okay.
Awesome. That's great. So we're going to move right on. So, I would like to learn more about Huckleberry. Like, what do you guys do? What products and services do you, offer? And then you could just go into how you started your work there. We'd love to know that.
Sure. So Huckleberry itself, Huckleberry Labs, we're a company that has an offering of an iPhone or Android application that you can use to log data for your child, and it shows you like different ways of looking at the data that you then log for the child. The idea behind this is that it will then offer services based on this. It's a big value add for parents to see what they're doing with their children right now, but it's also possibly in the future they could be doing more with them. So right now, one of the biggest areas of our focus has been child sleep, and this is something I know firsthand. I'm a parent of I'm a father of two daughters, and the first one did not sleep very well. And not having good child sleep, it really can affect you. Like I remember falling asleep when I was at National Renewable Energy Laboratory at my desk because I was up very late because my daughter wouldn't sleep because she wasn't well rested in the evening. So the idea is to really help parents so they don't have that experience. They know when is the best time to put their child down for a nap during the day so the child can be well rested. It's better for the child, it's better for the parent, it's better for the family. If the system falls out of whack, it can really be hurtful to the parent. So, and to the entire family. So the idea behind this is we have a product called Sweet Spot that if you log when your child is sleeping, it will then give you information about the next time which is best to put your child down for a nap. In addition to that, there's another product where we do a full-scale recommendation with sleep consultants, saying this is the best system of sleep for your child. So those are the primary products that's really moving out very quickly into other ways of supporting caregivers to help them do the best they possibly can. So that's sort of an overview of Huckleberry and some of the products that are currently under offer. There are others, but they're still being developed.
Right.
So, how did I end up working with Huckleberry? I was at the consultancy, and I was a principal data scientist, and I was looking for my next position. And consulting, it's an interesting life, but it's not really the right one for me. So I was looking for another position, and this came up, and I jumped at the chance because this offered me the possibility of working with something that I was really passionate about. And I really missed working with healthcare ever since I left the hospital. So this was a very good fit from a personal perspective. It's something I felt like I could really contribute to. So I joined based on those ideas. So.
Yeah, I know that. Like, definitely, sleep is a big, problem. A couple of months ago, I'd tried to have a conversation with a sleep doctor, and things with sleep does have effect over our hearts, and other parts of our bodies as well. So it's a very, very good problem. You're trying to solve there. Todd, you had something to say.
Well, yeah. So thanks for sharing more on Huckleberry. So is there a suggested age range that you guys have for, the sweet spot feature that you mentioned, or is it kind of appropriate for any child?
I would say it's pretty young children. It probably goes up to, it's probably reasonable to go up to about 4 years old, but then their sleep is probably pretty good. So
Okay.
maybe a little less than that is when it offers the biggest benefit, just because that's when it's more challenging sometimes to have the sleep problems. At least it was in my case, but I can't speak for all parents. Every case is going to be different, and every child is going to be different. So, but at the point where your child is sleeping through the night, then, which is, for me, was, I guess, around 4, then that's probably the limit for just sleep. So
Sure, makes sense. All right. And then my understanding is, I know you can't get into all the specifics, but you guys are using machine learning to help with these tools and offerings with Huckleberry. Anything you can share more on a broader level on that?
So, one of the biggest value adds that my team is able to do so far is really we're looking at how do we do things extensively and at scale with different systems. So, how can we use it's like a new buzzword, but MLOps, which is something that didn't exist a few years ago. It's sort of like DevOps machine learning. How can we make things operate at large scale for this for the company? So that's where we've really been focusing a lot of our effort is how can we really make things happen at large scale for this. Now, the data that we have a lot of data, but the values that we use are still derived from values that we get from working with experts in this field.
Okay, so anything you can share on, some of the challenges you're facing with Huckleberry Labs for developing machine learning products and models?
There are a lot of challenges, but a lot of the challenges are how do we move data from where it is to where a place we can do to give an excellent value add with the data itself, and then how do we move that around correctly without making sure that we keep everything secure from end to end is very important. And those are some of the challenges that we think about all the time. How can we make sure to keep the data secure? How can we make sure to move it around appropriately? And then what machine learning can we do with it that's really going to help the caregivers as much as possible?
I see. Yeah, those are definitely challenges that a lot of people face when they're working with data. And then, your job title is the director of artificial intelligence and machine learning. So anything you can share with us and our audience about what it takes to build a team of individuals working on artificial intelligence and machine learning topics and tools?
Yeah, this is actually a really, really challenging area in general, just because one, machine learning is very new. So there aren't a lot, like it's not like chemistry. In chemistry, you can always find people that have studied chemistry in graduate school.
Yep.
Look at their papers. It's very easy.
Yep.
But that's not the case in machine learning, because a lot of people going into it might not have any academic background in it.
Correct.
So it's a little bit, and this is not just for data science. I mean, I know that one of the best programmers I know has a degree in philosophy. The idea behind it is what people studied in school might not be directly connected to what they do. You can sort of look at their background and say they probably could be. I mean, from my experience, engineers tend to be excellent in data science. So it's really looking at their background and saying, hey, do they have the possibility of doing well? Then where do they fit into this? If they're just out of school, you might want to consider like a data challenge, like a data science challenge, not like one to test their intelligence, but one to really see, do they understand this? Have they used it before? Is it something that they're going to really want? And then you can look at where they've worked and what they've done in that. It's very different if you're hiring someone at a large organization, if you're hiring somebody at a startup. If you're hiring someone at a startup who's never worked at a startup, they might not really have a good understanding of the startup itself. So startups, you tend to wear a lot of hats, you tend to do a lot of different things. And if they've never done that before, they might not be used to it. But if you're hired at a big company, you might get hired just to do code review. So it's kind of different. So yeah, I guess there's different things that I found in my time that engineers tend to do really well. Scientists tend to make good data scientists if they've gone into it or if they have a background in programming. But it's also a lot easier to teach somebody how to program than it is to teach somebody how to think about data science correctly. So if they think about data science correctly, that's a heck of a lot better than if they just have a lot of good programming experience. That being said, software engineers tend to make very good data engineers because there's a lot of overlap. There tends to be a lot of database information. There tends to be a lot of moving things between databases. And a lot of that's done in software engineering. So a background in that could be a very good background for data engineering. And so MLOps is generally too new. Although we do MLOps quite a bit. This was something that we've learned as we went along. So in the past, we have people who've just been doing this before, so now they continue to do it. So really looking at past experience and trying to understand, is this what they want to do? Do they have a good propensity for it based on their academic background? There's even stranger things I've seen, like for instance, if you had someone who was in the military who studied electronics, they probably have a reasonable background to go into data science. And that's not something I would have expected. It's just something I've seen a lot. I actually do work with the veterans group, and a lot of the electronics technicians, some of them tend to even get PhDs in data science. Now, this is the past. In the future, we're starting to see people who do have a academic background in data science or data engineering. So that may change. It's sort of maturing as a discipline, and you might be able to hire your team in the future from people who have these degrees. But now it's still pretty challenging. So I think those tests can be pretty good. Having people do presentations has always been a really good methodology because you get to ask questions in real time and sort of see if they really have an understanding about what they're talking about.
That makes a lot of sense.
Yeah, that makes a lot of sense. Thanks. I'm curious, Yano, because I know you have a background in machine learning as well and AI. What are your thoughts on what Glen has to share about that?
Yeah, I mean, yeah, it's a very, very new space, and with new spaces, you have challenges that currently exist and challenges that are sort of yet to exist. And also the dynamics of the field is it's almost every day evolving. Like initially, it used to be like just this blanket machine learning, and then everybody kind of fits into this machine learning theme, but now it's moving towards oh, are you more into natural language processing, or are you into sentiment analysis? And the approaches for those different areas differ, as well. And so I think that, the more we're able to get into the details as to, what tasks, are involved in, so for example, if it were, a movie company, right? Would it be more of a recommender system specialist, who has experience in that space, as opposed to, someone who has just experience in voice? The more we begin to get into more of those details, the more we're able to actually improve and build, greater and better teams.
That's actually a really important point, because this is something I was thinking about not that long ago, but no one on my team has a title that probably existed when I started doing this.
Yep. So we're going to move right on, to, what are some of the ways you think that machine learning can actually help improve systems in the sleep industry, just in general? Or maybe just in the health industry, just in general, because I know you have, a passion for the healthcare space.
This is actually a really great question, because I feel like what everyone's focusing on right now is trying to replace doctors or trying to replace people in the medical system. Mm-hmm. And I don't feel like that's the right thing to look at.
I agree.
I feel like the biggest value add by far isn't being able to beat even really good doctors at diagnosing a particular disease. I think it's in operations, because in operations there are a huge number of problems and a huge number of inefficiencies that could be ameliorated using machine learning. You don't want to say, a radiologist can diagnose lots of different diseases. If you can diagnose one disease better than any radiologist, that's still not a huge value add, unless it's a super high value condition. But if you want to make all the radiologists 3 times faster, it's a huge value add, because now you've really hit the healthcare system, or you've really added to the healthcare system entirely, because you've made people work faster. I think and this is not just in healthcare, but I think it's even in like self-driving cars. You have to probably get an unbelievably massive data set, probably bigger than exists, to build entirely self-driving cars. Well, why not just make people help them out and assist them with driving? Why not just assist the healthcare system with operations? Because there are so many operational problems that just aren't being worked on efficiently right now. And I feel like there's a much larger value add to these. So, and the more you can cast these, what we think of as healthcare problems, in operational terms, you can see that they're really operational problems. So it's not that the doctor is not diagnosing it correctly. It's that it's not being communicated correctly, or it's not being set correctly in what is a very complicated system. So that's my opinion.
Yeah, that's definitely an interesting take on that. Thanks for sharing, Glenn. I definitely think that both Yano and I agree that we feel like machine learning is definitely not meant to replace doctors. And it sounds like there's a lot of value that could be added on solving these operations problems from a machine learning standpoint. So I guess, outside of the healthcare industry, any other applications? I know you mentioned self-driving cars. Any other applications or areas where you feel like, the machine learning or the operation side of machine learning is ripe for help and change on solving some problems?
Actually, I think in any system that involves humans who are trying to get information about a system from other groups, it could help there, because it really sort of, if you think of machine learning, it acts as a semantic layer that can really give meaning to a lot of these questions. So we can ask this question and it can say, hey, this is not just answer A, but this is why you're getting answer A. So, and maybe this means the future, at least the future from my perspective, could involve a lot more things like causal inference, where we're trying to understand why things are happening, as opposed to just getting the best answer, which has really been the focus of machine learning the last couple of years. So yeah, if we see a system like in-demand forecasting, that's a big problem. It's essentially an operations problem. So recommendations are essentially trying to take away. So if you think of it, I think of it differently. I think of a recommendation as trying to take away some of the burden put on your user. So your user wants to do something with your product, but you've taken it away by saying, here's part of a way to think about the right way of choosing your product, our product from this system that we think fits you very well. So even if they don't end up choosing it, you could look at the value of saying, hey, if they watch more videos on YouTube because of the recommendation we give, that's a value add, even if they don't watch any of the videos that we recommend. So I feel like that's a big value add to it, sort of helping humans understand things better and then helping humans do less. And those are areas where I think it could really excel in the future. Maybe that means more probabilistic modeling.
For sure. Definitely agree with you there. Thanks for sharing, Glenn.
Excellent. Thank you so much for sharing. Just as we, wrap up here, are there any real world applications that you foresee machine learning being of, great help, to at the moment? Any real world applications you foresee machine learning being of a tremendous help to?
One of the areas that it's really making major strides in is in the military. So the military itself is a lot of, we see systems that are extremely complicated, and I think it's going to make a huge value add to those systems, just because they're so complex, and they really just don't have any, there's not going to be, the way we're doing things now is probably not the way things are going to be done in the future. So, and I do see a lot of effort going into that right now. It could also be in other highly inefficient programs. So, but part of that might not be machine learning. It could just be even better ways of understanding your data and understanding data problems. So, I guess in the future, the way I see it maybe isn't more machine learning, but machine learning appropriate in data being used very well. So, and the government is an area that has a lot of data, but maybe it's not being used the best as it possibly could. That could also be true of other large companies as well. Like I remember talking to a friend who was at a very large company, and she was like, yeah, we have many, many databases. We can only access a handful of them. And it's like, well, that is a problem that you could see a data engineer working on, even though it might not be in machine learning in the near term. It's a big problem because people don't have the information they need in the way that they need it. Now you could see making that information accessible and then using machine learning or different probabilistic modeling to give you more information specifically about that data.
Yep. I do agree with you. Todd, you were going to say something?
I see what you're getting at there. Thanks. We definitely feel the same way about there being great value to add to the military on solving these types of problems. Thank you so much, Glenn, for taking the time today. We really appreciate it.
Yes, Glenn. It was fun having you around, and some exciting things you had to share here.
Thank you very much for inviting me. I really appreciate it. It was great talking to you guys.
This has been the AI Innovation Space, sponsored by Ellumen. Thanks so much for listening.
Be sure to connect with us through LinkedIn and the Ellumen website to learn more about how AI and emerging technology can help you. Also, be on the lookout for our next episode coming soon. Thank you so much for joining us. Have a wonderful day.